This is lesson 8-4, factoring by grouping.
So we do this factoring when? Factoring by grouping is a part of the AC method procedure, and this procedure will be used when we factor trinomials that look like ax squared plus bx plus c. In other words, there's a number or a coefficient in front of the squared term of the trinomial, and we'll be doing that in our next lesson. Factoring by grouping should always be done with any higher degree polynomials or any polynomials that have more than 3 terms. Typically in our studies, we'll be doing ones that have 4 terms. Before you attempt any type of factoring by grouping, first be sure that there are no GCFs that can be factored out, and be sure that your polynomial is in standard form, which means, of course, that the powers start at the highest on the left and end up with the lowest on the right. Here's the procedure for factoring by grouping. Again, as we said on the last slide, look to make sure that there's no GCF that can be factored out. If there isn't one, continue on. Split your terms into 2 groups. When we're working with 4 terms, you want to split it so that it has 2 on each side. Next, use GCF factoring to factor each side. When you do that, you should end up with a match on both sides of your line that you provided in the parentheses. The first thing you want to do here, and you'll notice my example on the right, is you want to separate the 4 terms into 2 groups of 2. Then I want to factor this side, which is the left side, and the right side, using GCF factor. As you can see on the next line here, I've done that. The GCF on the left side is 3n squared, and I'm left with n minus 4. The GCF on the right side is 2, and I'm left with n minus 4. What I'm talking about when I say a match in the parentheses is that you can see inside the parentheses now, I have 2 n minus 4s. Next, rewrite your 2 binomials, and you want to take the match and the factors that you pulled out. So watch what I have here on the right side. I now have 3n squared plus 2, so this one here and this one here goes to this binomial. Again, you don't have to write it first, but it's just my tendencies of what I do. And then the match gets written right next to it. It's almost looking like a reverse double distribution. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try it on your own. We'll start with the left, and I will again split them into 2 halves. And in factoring the left side, my GCF is 2t squared, and I'm left with 4t plus 7. On the right side, my GCF is 5, and I'm also left with 4t plus 7 in parentheses. So my final answer for the left side is 2t squared plus 5 times the quantity 4t plus 7. On the right side, I have a GCF first, so I need to factor that out. My GCF there is 4q. I'm left with q to the third minus 2q squared plus 3q minus 6. Now I want to factor what's inside the parentheses. I'm going to split the 4 terms into 2 groups of 2. Leave the 4q alone and drag it down with you the rest of the time. So 4q goes down, and then in the parentheses, on the left side, I factored out a q squared. I'm left with q minus 2. On the right side, the GCF is 3, and I'm left with q minus 2 in that set of parentheses as well. Again, drag the 4q down, and the q squared and the positive 3 go right in the first binomial, and the q minus 2 goes in the second binomial. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.